Okay, so explain why the TiF2 minus ion has the shape that you have drawn in F part 1. So why this is so? It's trigonal bipyramidal, right? So why this is so? They're asking.
Due to it having 5 bond pairs and no lone pairs?
Yes. So there are 5 bond pairs.
Yeah.
There are 5 bond pairs. Which one of the first, second, or third ionizations of thallium produces an ion with the electronic configuration of xenon and 5d10 and 6s1? 5d10 and 6s1.
Yeah. Um.
First of all, first of all, you need to know the original configuration so that I can have an idea after losing electron what would be the final configuration.
Uh. Wait. Which one of the first, second, or third ionization? Okay. So thallium has 1 second. Thallium has an atomic number of 81. So
Basically, its original configuration is 5d10, 6s2, and 6p1.
and
This is
how
the
did you find that?
original configuration. Basically, it's in the sixth period, isn't it? It's in the sixth period. Yes,
Yeah.
check it. And it's in the third group. Am I right?
Yeah. Yep.
So it's, yeah, so that's why sixth period and third group. 2 plus 1 is 3.
Okay.
And I knew school is school, public is school, public is school, doubt public is schools. 1 is 2, 2 is 2, 2 is. Of course, xenon is what? The proton number of xenon is neon is 20. He ni argon is 18. I don't know. Like, so basically the configuration of thallium is this. This is the original configuration, and what they have given 5d10 and 6s1. So how many electrons are removed from thallium?
Two. So
Yeah,
second.
exactly. So 2 electrons are removed. So if the 2 electrons are removed, so I am supposed to write that it's what?
Second.
It's second, yes. Okay. This question is about enthalpy changes. Define the term standard enthalpy change of formation. Mhm.
Uh, I don't remember this theory part. Like the
Yeah, I can say that it's the enthalpy change when 1 mole of a compound is formed from its elements in their standard states under standard condition.
okay.
Energy change when 1 mole of a compound is formed from its elements in their standard states Yes, I was telling you that the direct route is equal to indirect route. So I can say that when I'm going to prepare carbon dioxide, so there are two ways to prepare carbon dioxide. Number one, this is called the direct method. And on the other hand, I can prepare carbon dioxide in two ways. First of all, carbon monoxide would be produced. And when carbon monoxide would react with oxygen, so it would be producing carbon dioxide. So carbon dioxide can also be prepared by the two methods. Can also be prepared by the two methods basically, right? So what does it mean? It means that uh, I can write the definition of Hess's law that the product of a reaction is independent of the route taken. Whatever you are going to take the route, I need carbon dioxide. It's up to you which method you are going to opt. So the energy change would be the same. Energy change would be the same. If you are doing a chemical reaction in one step, and if you are doing the same chemical reaction in multiple steps, so the overall energy would remain the same. So I am supposed to write that um, the the enthalpy change, or I can say the energy change is independent. It would not change. It would not change, is independent. Whatever whatever the route you are going to take, it's independent of the route taken. It's called Hess's law.
Right.
Generally, we say that direct route is equal to indirect route. And then they're asking why the standard enthalpy change of formation of O2 is zero. It's a diatomic element. All the diatomic elements or the simple one element like sodium, magnesium, copper, silver, gold, and for the diatomic H2, N2, O2, F2, Cl2, Br2, I2, AT2. So overall, the total diatomic elements and the single metal, so the enthalpy change would be zero. So I am supposed to write that it's an element. O2 is an element, N2 is an element, H2 is an element. So that's why the enthalpy change is zero. So I can say O2 is an element. That's why the enthalpy change is zero. We can't form an element. We can form a compound. We can form a mixture. We can't form an element. Like we can't prepare sodium metal, of course. So its enthalpy change is zero. Use table X and the equation to calculate the enthalpy change for the reaction of ammonia with oxygen to form nitrogen monoxide. So the equation is given to you. That is this one. Ammonia is reacting with O2 to form NO and H2O. So what you have to do, they are asking calculate the enthalpy change. But they are not asking to draw the Hess's cycle. So you are not supposed to draw. Directly you can solve it. Of course, what's the formula to calculate the delta H of delta H? Yes, what's the formula?
Of calculating delta H, you're gonna write like the lines basically like Hess law, right?
Okay.
and you're gonna check if they are going like in the direction of the arrow or not, and then you're gonna add them up
But
and
the thing
check.
is that you are not supposed to draw the Hess cycle. You can directly apply the formula that is product minus reactant, and that's it.
Okay.
Yeah, you can directly apply the formula. Delta H is equal to product minus reactant. Delta H is equal to product minus reactant. So I can write product is NO and H2O. NO is 90, H2O is 242. NO is 90 times 4 plus H2O is 6, and the value for H2O is minus 242. This is minus 242. This is the product minus reactant. NH3 and O2. NH3 is 4, O2 is 5. 46 into 4 and 0 multiplied by 5. Negative 46 into 4. And that's going to be 0. I'm not supposed to solve it. So that would be your answer. Is this negative or positive? Overall answer.
Um, it depends, yeah. Like, what is this enthalpy of formation?
What's the
So,
answer for this?
is it? I think exothermic, right? Of formation because it gives out
Formation,
heat. I think.
formation may be exothermic, formation may be endothermic. We can't
I
say.
think it. I think because formation, I think is endothermic because things are being formed, energy is being
No, no,
taken
no,
in.
no, 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 no. Formation, I can't say. It may be endothermic, it may be exothermic.
It could be
Because
both.
it depends on the, it could be both, because it depends on the value given. Sometimes, what's the answer for this question? What's the answer?
Or you can calculate it. Um, 1 second. I'll just get my calculator. Negative 908. It's exothermic.
Negative 908 kilojoules per mole, right?
Yep. So it's exothermic.
Barium metal reacts with water. It's more reactive. Down the group reactivity increases, right? It's below the group 2. Write an equation for this reaction. They haven't mentioned that. Is this cold water or a hot water? Remember, if nothing is mentioned, so I would be considering that this is the cold water, the water which is at room temperature. Of course, the room temperature is 25 degrees Celsius. I'm supposed to write barium will react with water. It's gonna produce barium hydroxide, not oxide, not oxide, barium hydroxide. Remember, if they would be giving us hot water, then I would be writing barium oxide. This is an important point. You have to see the state sample for water. Sometime he would be giving you water gas, water vapor. Sometime he would be giving you water liquid. State sample is L. So you are supposed to form hydroxide. If state sample is G, that is gas. So you are supposed to form oxide, liquid, hydroxide, gas, oxide. Gas means hot water, or sometimes they would be giving you steam, the same thing. Hot water or steam, the same thing. You will be forming metal oxide when they will be giving you water. Of course, the water is liquid at room temperature, so then you will be writing hydroxide, metal hydroxide, and hydrogen gas without state symbol because they have not mentioned. That's why. A solution containing barium ions can be used to show the presence of sulfate ions in an aqueous solution of sodium sulfate. We'll write the simplest ionic equation for the reaction that occurs and state what is observed. Basically, you are supposed to form a barium sulfate. You are supposed to form barium sulfate. So how you will be forming barium sulfate? You have to write down an ionic equation, of course.
Okay. Um, Ba, and barium is 1 second. Ba2 plus SO4 2 minus, I think will be the ionic equation. So with sodium, 1 second. So you'll first write sodium sulfate, maybe, I think, or you're gonna write here Ba2 plus SO4 2 minus. Then yeah, okay. The observation is white precipitate, right?
White precipitate, yes. Okay, so observation, presence of white precipitate. Or you can say,
Barium
or
ions
you can
are
say
barium ions are like
white
insoluble.
solid. All
Barium,
ions are soluble. All
in
ions are
them.
soluble. Remember,
Oh,
barium
right.
sulfate is insoluble. When
Right.
something when something has a charge, whether it is a positive or negative, it would be soluble. See this one?
I'm not sure about the answer then.
Yeah, this one.
I'm not. Yeah, I
This
don't
one.
know the answer. Yeah, this one.
State one use of barium sulfate in medicine. Explain why this use is possible given that solution containing barium ions are poisonous. If you remember when I was telling you X-rays, if you remember, I was telling you X-rays, basically, X-ray is used to identify the bones breakage. But what if I would be doing an X-ray for the soft tissues? I remember I was telling you, so I told you that you have to take the barium. You have to take the barium. So what it does, basically, the thing would be visible in the presence of a barium. So they are saying state one use of barium sulfate in medicine. Explain why this use is possible given that solution containing barium ions are poisonous. So in the use, I can write that barium meal. Before going to do an X-rays, we have to take a barium meal. An explanation of course, I can say that barium meal use to take before X-rays of soft tissues. Student carried out a laboratory experiment. Okay. Describe, deduce two reasons why the student's value for the standard enthalpy of combustion of ethanol is different from a data booklet value of a minus 1279 kilojoules per mole. First of all, it's of 5 marks. You have to calculate that. Use the student's results to calculate a value in kilojoules per mole for the enthalpy change. When 1 mole of ethanol is burned, you have a data. You have to first calculate the delta H and then you have to compare it with this value, they are saying that why the student's value ethanol is different from this value. Then you have to explain it why they are different. First of all, you have to calculate the value delta H.
Okay. Sir, so what formula do I use for getting delta H?
Is MC
PV equals
delta T.
to nRT?
MC delta T.
What?
MC delta T.
MC delta T, right?
Yeah, yeah.
And like delta H is energy, so like what the no wait, delta H is the what again? Energy is gonna be Q, right? Q is energy, yeah?
Yep.
Right. So temperature I know is 5.5. T is 5.5.
And mass is 5.
Mass is 75, yeah. Specific
This
heat
is C.
capacity is 4.18.
And this is 5.5.
Yep.
What's the value?
1724.
It's in joules. What would be the answer in kilojoules?
Uh, Divided by 1,000.
Yeah, 1.724 exponent 3.
Yep.
So of course, this is the value in kilojoules. I have to find out the value like this. Kilojoules per mole. Kilojoules per mole. So I have found this value, that is this 1.724 times 10 to the power 3 kilojoules energy is released when I have this much moles, that is this. When I have this much moles, that is this. So what would be the energy? What would be the energy if I have 1 mole?
Q over M, right? I think it's a formula.
Yeah, the same thing.
So, so I just have to divide them by each other.
Yep.
Answer is 7.18 times 10 to the power of 10. Oh, wait, no, not 10 to the power of 10, sorry. 1 second. Times 10 to the power of uh 7.20 times 10 to the power of 5.
Kilojoules.
Yep.
So now you can see the values are different.
Yeah.
This is different from this one. Why there is a difference between the calculated value and the expected value? Like the thing that I have seen in the booklet, the value is that is the true value, and when I have calculated, so my value is different from that. So what are the possible reasons that I am getting the different enthalpy change as a result of this experiment? So I can say that there is a heat loss when I was doing an experiment. So might be possible that there would be a heat loss. Like let's suppose tripod stand is made of what's going on in this one? Enthalpy change was burned. Yeah. Tripod stand is made of iron, so iron is going to absorb heat. And when I'm going to get the beaker is made of glass, so glass is going to absorb heat. So when the glass is absorbing heat, so rest of the heat I would be calculating in terms of q is equal to mc delta t. So of course I'm getting less than the original value. So I have to write down the possibilities. So first of all, I am supposed to write there is a heat loss. This value is different due to heat loss, or I can say incomplete combustion. Yes, see this one?
Um.
It's related to percentage uncertainty.
Yeah. Yeah. I'm not sure. Like I know it's 0.1 degrees,
When
so it can be like 5.51 or 5.49, but I'm not sure about this uncertainty. I've done it in
like
physics
we
too.
have okay, we have two apparatus by which we can take two readings. Like let's suppose from the burette, we take initial reading and the final reading. So of course, when you will be taking an initial reading, so the error is would be with you. And when you will be taking the final value, so the error would be with you. Let's suppose error is zero point 0.1 or zero point 0.01. What the error is, same goes for temperature, same goes with thermometer. We take, I'm talking about the enthalpy change because we need the difference in temperature before combustion and after combustion. So we have to take the temperature twice. So
Okay.
the error would be multiplying by twice. So first of all, then I have to write down 2 multiplied by this is the uncertainty of the thermometer, that is zero point 0.1, it's the least count, divided by the total temperature as a result of this, divided by the total temperature, that is this, and multiplied by 100. That's gonna be your answer. What's the answer? So I told you why I'm going to multiply this by 2. It doesn't mean that all the time it would be multiplying by 2. No. When you will be solving the burette, so then you have to multiply this by 2. And when you will be solving the temperature, like the thermometer, then again you have to multiply this by 2. What's the answer? Are you solving this?
Yeah, yeah. I had my thing in gradients. Just changing it. Um, his answer, wait, 3.3666. No, 3.363636. It's recurring. 40 over 11. That's the answer, right?
Suggest one way that the student could reduce the percentage uncertainty in the temperature change using the
He
same
can
apparatus. Hmm?
repeat the experiment and find the mean, I think, or the average.
You can repeat
Like,
the
yeah,
experiment.
not repeat it, like do it more times, like repeat the experiment, yeah, and get the average of the answer that he gets each time, I think.
First of all, you can see this. It's the mass of water that is 75 grams. Okay. In like it's a general like when you will be increasing the denominator, when you will be increasing the denominator, okay, so the percentage uncertainty will be decreasing, isn't it?
Okay.
So I have to increase the temperature. When I will be increasing the temperature, automatically the percentage uncertainty is going to decrease, isn't it? Because they are inversely proportional. Makes sense,
Right. Yeah.
right? They are inversely proportional to each other. So how can we increase the temperature? How can we increase the temperature? So you have to take more ethanol. You have to take more ethanol. If you can see this, what the sample you have taken for the combustion, ethanol. If you will be taking more ethanol, it means that they will be giving you more temperature. So the temperature of the water is going to increase in a greater manner. So it means that the temperature is going to increase. When the temperature is going to increase, so the percentage uncertainty will decrease. Okay.
Okay, so we have to increase the temperature basically.
So burn more ethanol.
Okay.
See this one.
Think sulfate ions will be there, right? So there would be like white precipitate as the observation one, that could be it. Um,
In terms of
uh,
electron, okay. What happens to the iodide ions? What happens to iodide ions in this reaction?
I can see that they are being they're like splitting from sodium, and
Mhm.
they are in like diatomic form.
State the change in oxidation state of sulfur. So initially the sulfur is plus 6, I think so, yeah. And then this is plus 4 minus 8. This is minus 2. Yep, this is minus 2. And then during this formation of H2S and deduce the half equation for the conversion of H2SO4 into H2S. So H2SO4 converts into H2 is, then you have to balance this equation as I told you. So I'm supposed to write four water molecules because oxygen is balanced
Yo,
by
what's this
water. When
loud?
I have written four,
Yeah, now, hello?
now it's clear.
Yeah, now it's clear.
Okay, so I was saying that I was telling you how to balance a redox equation. How to balance redox equation, in that I told you that oxygen is balanced by water. So there is four oxygen. I have written four water molecule. When I have written four
Okay.
water molecules, so this is gonna be 8H positive, isn't it? 8H positive, then we have to balance the number of charges, number of electrons, 0 and 0. This is plus 8. So I'm supposed to write 8 electrons to balance this equation. Okay, that's the half
Okay.
equation for H2SO4. Then I'm going to write I minus, okay, iodide ions into iodine, I2, and I'm supposed to write 2.
All right.
To
And two
balance the
electrons,
charge,
yeah?
I have to write 2 electrons. Yep.
Right.
Yeah. And
Okay.
then what you would make observations to what you would make when this reaction occurs. So first of all, what's the color of this one? I2. I can see the color of iodine. I can see the color
Yeah.
of iodine. It's a gas. So I can see
It's, I think, yellow, right? Pale yellow.
observation is
Or like
formation
iodine is blue
of
black as well.
purple vapor when it's in the form of gas. So I can see the purple vapors of
Oh,
iodine.
purple, right.
And of course, yeah, and this is ionic compound. It's a sodium iodide. It's a white solid because it's not a transition metal. It's not colored. It's a white solid. Okay. So you can see that again. Then what should be the second observation due to this one?
I think due to sulfate, like this SO4, yeah, there could be white also, white precipitate. Or you already said
Bad egg
purple
smell.
vapors and white. Okay. And what again?
It's a rotten egg smell
Oh,
due to the formation of H2S.
okay.
Yeah, see this one.
All right. Okay. Of Q, R, and S. I think S can be ammonia. S can be ammonia, I think,
S can be ammonia.
or maybe
White precipitate,
no
no
white precipitate.
change. Red litmus paper, yeah, exactly, because it's going to
Right.
react with NaOH. It's a strong base.
Right.
Yep, it may
That
be ammonia. Yes.
could be
No
ammonia,
change
and
observed. No change observed. Okay.
yeah,
So
and
identity of S, you have to write down the compound. They are saying table 3 shows observations of changes from some
B
test tube.
ammonium sulfate,
Exactly. Exactly. Yes. Ammonium
white precipitate, right?
sulfate.
So
So that's gonna be NH4 to NSSO4. And what about Q? No change observed because nothing, no sulfate. AgNO3
cream
pale
color.
cream, so means that bromide,
Uh,
isn't
there's
it?
cream color. So
Bromide. And
uh,
if it would be yellow, so it would be iodide. If it would be white, it would be chloride. So it's
yes, exactly.
bromide. And NaOH, it's going to give you the white precipitate. So
Barium,
what's
barium,
that?
I think. Barium bromide or something.
Mm, no, it's not barium.
Calcium.
Yep.
Okay.
You can write calcium, you can write magnesium, like above metals in the group 2 basically.
Group
So
two,
I
right?
can write magnesium and next chloride or bromide.
Um,
Or
right. I would like to say it could be carbon dioxide, but it doesn't have white precipitate, right? But it has bubbles of a gas, but I'm not sure.
exactly, it's a bubbles of a gas.
But there's no
So
white
bubbles of a
precipitate.
gas means so no. So nothing. If there would not be a what do you mean by this? There is no white precipitate. If you would be adding barium chloride, if you are getting the white precipitate, so the white precipitate is due to the formation of barium sulfate, right? There is nothing to do with the sulfate. But I can say that it's a carbonate. Understood that because carbon dioxide is released, it's a carbonate. But which metal is there? Which metal is there? Then you have to see this one. White precipitate, bubbles of a gas. White precipitate means that um
It can be any from group two, right?
so you were
Apart
saying
from
that
barium.
no change is observed. That's why you were saying that it's not barium.
No, no, I was saying that it cannot be carbon dioxide because there's like white precipitate, but I think it was carbon dioxide. Like I wasn't exactly sure. I thought like
Yes.
the answer would be carbon dioxide itself.
It's barium carbonate.
How is it barium carbonate?
When it's reacting with H2SO4, it's going to give you the white precipitate. It's mean that barium sulfate is being formed.
All right. Okay.
Of course, barium carbonate would not react with barium chloride, common sense.
Right.
Yeah, it's a 4 marks question. Write an equation, write ionic equations for each of the positive observations for Q. Write an ionic equation to show the identity of the gaseous product produced by R with HCl and by S with NaOH. Now you have to write down ionic equations, right? So when I have, like, first of all, if you can check Q, for Q, no change is observed. Pale cream precipitates are formed. White precipitates are. What do you mean by the white precipitate? You know, calcium. Calcium would be reacting with calcium 2 plus. Of course, it's in group 2, so the charge is +2. Would be reacting with OH minus, and it would be
Sir, I have
producing
a
calcium hydroxide.
question.
That's a solid. Mhm.
Okay, I have a separate question, which is in Oxford AQA's past paper, yeah, the AQA International, that one. I have ATP, right? Like alternative to practical, right? So similarly, in like IGCSEs for Cambridge, we had like a test for anions and aqueous cations and gases and metal ions, right?
Mhm.
We had that in paper 6, right? If you know.
Yes. Then.
So is do we have like a similar paper which contains all of those tests in Oxford AQA?
Like you're asking that, will they be giving you all the observations and the test? You are asking this question.
Yeah, in my alternative to practical paper.
You're not supposed to memorize few of the test.
Okay. All right.
What about that next equation?
Um
First
Wait.
of all, I took the idea from this one. When it's reacting with NaOH, it's going to give you the white precipitate. Of course, it's gonna be calcium hydroxide.
Yeah.
And what about this one? It's going to give you the pale cream precipitate. Of course, silver bromide is formed. How the silver bromide is formed? So silver is reacting with bromide.
Okay.
AgBr is formed. And then they are asking about R. In R, what's going on? In R, they are giving us bubbles of a gas. Acid is reacting with carbonate. That's why carbon dioxide is released. So acid is represented by H plus. It's reacting with carbonate. That is 2 minus. Carbonate is always 2 minus. Then as a result of this, carbon dioxide and water is formed. Then what's going on in R? You can see white precipitate. Bubbles of a gas is formed. So white precipitate gas. Gas is produced. Gas is produced by R. So this is the gas. And then we have to check S. What's going on in S? In S, white PPT, it's due to the formation of sulfate, then gas, ammonia gas. Yes. So how
Okay.
the ammonia gas forms when NH4 plus reacts with strong base, it produces ammonia and water. So this is about S. This is about R, and this is about Q.
Okay.
This is about Q. That's it for this paper.